All right, students. So this is one of the questions. So I disagree with all the choices, and I'm going to do my own solution. Okay. So when you look into my solution, give your comments as to what do you think is the correct answer. So I have taken an approach which is slightly different. I think I'm conceptually right, whereas the four choices which are given are not correct. So watch my solution, put your comments, and tell me if you agree or disagree with my solution and give a logic for that. Thank you very much. Let's start with the solution. All right, students. So this question, let's read it first. This says that while slipping on the rough spherical surface of radius r. So let me just mark the radius of this hemisphere. Let's say this is the center. It's a hemisphere, right? So it's just a half one. Okay. And it's a spherical surface. The block of mass m comes with a velocity of under root of 1.4 gr at the bottom point P. So point P, the velocity is equal to under root of 1.4 gr, where r is the radius of the spherical surface. And what is the work done in slipping the block from B to C? All right. So this is your point A, and this is your point C, which is directly opposite to A if you notice. Okay. So what are the thoughts in your mind? Okay, let's discuss this question. Yeah, I hope the situation is clear. The data is available to you. What are the various thoughts that come in your mind when you want to solve a question like this? Okay, what comes to my mind is that obviously there is a friction involved which resulted in loss of energy. So let's say the loss of energy which happened from here to here, we have to find it, which is dissipative work, right? So if there was no friction, okay, if there was no friction, then this whole mgh, okay, this whole mgh would convert into half mv at the bottommost point v squared at the bottommost point. Now let's say what is the velocity you will get? You will get under root 2gh is equal to v bottom, okay, which is how much? Which is the height you have lost, okay, by virtue of this is r, right? So this is given to be h. Okay, so you are getting VB as this, whereas the actual velocity you have got in the question at the bottommost point is under root of 1.4 gr, right? You can see the difference. This is under root of 2. This is under root of 1.4 r. I'm assuming the in the question what they're showing is a semisphere, okay, and therefore the height which is being referred to is basically equal to r, okay. Yes. So I think I'll just correct that diagram here. So the body is located right at the half the sphere, which is somewhere here. Okay, so the body is located here, and this particular height, okay, is the radius. I hope the correction is visible to you. It is half a sphere. So and therefore the loss in energy. Okay, so the loss in energy is how much against the friction is equal to half m v b. This is the kinetic energy when there was no friction, and now the kinetic energy when there is friction, which is this velocity, right? So let's call it b dash, okay, b dash squared. So this is equal to half m. What is the value of vb square? It is 2gr minus half m. And what is the value of b dash square is equal to 1.4 gr is equal to half m. So this is 0.6 gr. Okay, this is the loss in kinetic energy. So the work has to do two things. One, there is a loss of energy, which is to the tune of point 0.8. Sorry, the energy lost is to the tune of zero point 0.3 GR, right? So you have already lost this much energy. So first job of the work done is to give you this energy back. Okay. So if you get back this energy, now your level is same as what was here, right? So if you are at zero point 0.7 GR, which is this 0.7 GR, and I give you zero point 0.3 GR, how much energy do you have? You have the same energy you had here because the work gave it. Now, you also know if you get back your GR, which was your energy here, right? If you start going back with GR, you will again lose point GR, sorry, 0.3 GR because that's a loss, right? There's a loss you have. Half zero point 0.6 gives you 0.3. So work again has to give you zero point 0.3 GR to ensure that you reach it. 0.3 GR, the first 0.3 GR is given to you only to ensure that whatever you lost from here to here is compensated. So you got compensation and you became 0.GR, right? Now if you start going up with this energy, you will lose another 0.3 GR, which means the work also needs to provide that. The total energy, therefore, which is being provided to you by the work is 0.3 GR and another 0.3 GR, which is 0.66 GR. So to me, the answer is 3 by 5 GR is the amount of work which needs to be provided to this body to ensure that first, the compensation for loss here happens. It gets back its initial energy, and then it is also compensated for the future loss of 0.3 GR. So I hope you like my explanation, and you can still comment on my approach. So thank you very much, and do not forget to subscribe to this channel because we're giving detailed explanation and also trying to correct a lot of garbage which is available on internet. Thank you very much.